Hi, in this video we are going to see about frequency reuse. So cellular technology enables mobile communications because they use a complex two-way radio system between the mobile unit and wireless networks. So it uses radio frequencies or radio channels over and over again throughout a market with minimal interference. So it serves a large number of simultaneous conversations. So this concept is the central to cellular design and is called frequency reuse. So this is how a cell with antenna will look like. You have sector 1, sector 2 and sector 3. You have an antenna. This is a cell, right? You have a base station with directional antenna, right? Then cells with the cluster. So here is a cluster. This is a cluster. And you see replications of clusters here, right? Then most frequency reuse plans are produced in the group of 7 cells. Most of them are in 7 cells. So same frequency is reused by each sector. Same frequency is reused by each sector. The number of cells per cluster defines the reuse pattern, and this is a function of cellular geometry. Okay, the number of cells per cluster defines the reuse pattern. So cell sizes may vary from 100 kilometers. 100 kilometers we may have different cell size. 35 kilometers we have different cell size. And it also depends on the user density, geography, transceiver power, etc. Okay, the hexagonal shape of the cell is ideal. Okay, by limiting the coverage area to the boundary of the cell, the channel groups may be reused to cover different cells. Okay, you are limiting the coverage area to boundary of the cell. So what happens? Channel groups are reused, and this helps in covering different cells. So now consider a cellular system which has total of S duplex channels, right? Now each cell is assigned K channels, right? Each cell will be assigned K channels, right? So the S channels are divided among N cells. S channels are divided among N cells. So cells channel, right? So this is what. So now the total number of available radio channels are S is equal to K into N. S is equal to K into N, right? Each cell, for one cell you have K channels, right? Then N cells you have K into N. For one cell you have K channels. So N cells you have K into N. So that is the number of available radio channels, which is S. Okay. So then N cells which use the complete set of channels is called a cluster. So N cells, it is called a cluster. So now the cluster can be repeated M times within the system. Okay, the cluster N can be repeated M times within the system. So finally we have M into N, right? So now the total number of channels C is a measure of capacity. C is equal to M into K into N, right? M is equal to K into N, because M it is repeated. N cells they have K channels. N cells they have K channels. So M into K into N. So K into N we have already seen that it is S. So finally C, that is MS. Okay, number of channels C is measure of capacity is MS. So the capacity is directly proportional to the number of replications of M. Okay, the cluster size it can be 4, 7, 12 or whatever this. But the smaller N is desirable to maximize the capacity. The frequency reuse factor is given by 1 by N. So this is a frequency reuse factor. Like you have, this is a cluster, this is a cell, this cell, this is a cell, this is a cell. These 4, they form a cluster. Okay, so here you see you are going to reuse the pattern of 4. So this is how it is, A, B, C, D. Here we are using in a larger area, you can see how it is getting repeated, reused. Now here if you see, you have cells and it's a cluster of 7, right? This is being reused here, right? It's a cell cluster of 7.